If you're a .NET developer building APIs, you have to take care of global error handling and also prevent leaking sensitive information about your API to your API clients. In this video, I'm going to show you two ways of how you can solve this. The first one is using middleware, and the second one is using the new exception handler feature. I'm going to start from a system that doesn't currently have global error handling implemented, and we're going to implement it in two ways. As I said, we're going to use middleware and the newish exception handler, which came out in .NET 8. But let's first talk about the types of errors that you can encounter inside of a typical .NET application. I'm going to take the create meeting use case, and I'm going to show you just two quick examples. The first one is using some sort of validator to validate an incoming request. And in this example, we're throwing an exception when we run into a validation failure. Also, if we run into some preconditions, let's say we want to create a meeting using an organizer ID that doesn't exist inside of our system, we can throw some generic exception, like an application exception, or a more specific one, let's say organizer not found exception. Now, in general, I'm not in favor of using exceptions like this, but they're still commonly used in .NET applications, so it makes sense to handle them with some sort of global error handler. Now, where this use case is invoked is from my API endpoint, and if I don't handle this exception within the API endpoint itself, it's going to bubble up to our API client. So let me show you what happens when we run into an exception. My application is running behind the scenes, and I'm going to send a request to create a new meeting, and I'm intentionally specifying an invalid request where the title is empty and the start time of the meeting is in the past. So if I send this request, we're going to immediately run into a validation exception, and from the exception message you can see that the title property has an error and also the start time. So if I press continue, we are currently going to expose this through our API response, and you can see that this is now leaking the complete stack trace, and this isn't something that you want to do inside of a production system. So let's say I fix this. I'm going to add test as the meeting title and move the start time to the future and resend this request. This time we run into a different kind of exception. This is a precondition failure, checking if we have a specific user present in our system, and because the user doesn't exist, we are throwing an exception. This is again leaking sensitive information to the application stack trace that we are exposing, and this is what we want to prevent with a global error handler. So let me show you how we can solve this. Let's say I create a new type inside of the exceptions folder, and I'm going to call this type the global exception handler. The first way I'm going to solve this is using middleware, and I want to use conventional middleware. So what I have to do here is implement a class that has a public async method returning a task, and this method should have a signature called invoke async. This method is going to have one argument, the HTTP context, and we also need to inject another value through the constructor, which I'm going to call the request delegate, and I'll just use primary constructors, and what you have to do is invoke the request delegate and pass in the HTTP context. So around this, we can now build a global exception handler by wrapping it in a try catch statement. In the try block, we want to execute our middleware, and in the catch block, we want to handle this exception somehow. So first, we might want to add logging for this exception. So I'm going to inject an ilogger inside of my global exception handler, and instead of saying console write line, let's do logger log error, and I'm going to say unhandled exception occurred as the message. And I'm also going to specify the exception as the first argument here. Now, what about actually handling the exception and returning this as some sort of response to our API clients? We could handle it like this by creating a ProblemDetails instance, which is a very common standard for returning API errors, and then writing this as a JSON object in the response. We could use the exception name as the ProblemDetails type. The title could be something like an error occurred, and the detail can contain the exception message if this is something that we want to expose to the API consumers. I'm also doing a switch on the exception type, and this allows me to control the status code based on the specific exception that I want to handle. So let's say in case of an application exception, I want to return a 400-byte request, and in all other cases, I want to return an internal server error. And in order to test this out, we have to include this middleware inside of our application, and I'm going to do that right here by saying app use middleware, and I'm going to specify the global exception handler. So let's restart the application, and then I'll resend this request to try to create a new meeting, and we're going to land on the breakpoint at the start of our middleware. Now I'm going to invoke this, and we run into an exception, the exception being our application exception that the organizer isn't found, and we're going to log this as an error to the console. If we're using something like OpenTelemetry, this is going to be sent to our monitoring dashboard where we can observe the specific errors that we run into, and then we're going to do a switch on the exception type. In this case, it's an application exception, so I'm setting the status code to 400 bad request, and finally I'm going to write this as a problem details response, and if I press continue, we're going to get a 400 bad request inside of Postman and the problem details object in the response. If we also take a look at the application headers, note that the content type is application JSON, even though we are returning problem details, and it could be application problem plus JSON. And I'm going to show you what the correct content type to return is if you care about REST API semantics. Now, just to demonstrate the other case, I'm going to omit the title and I remove the breakpoint behind the scenes. And in this case, we get back a validation exception, and the detail contains some of the problems that we ran into, but in this case it would be more appropriate and useful to somehow return the specific errors that we ran into. So let me show you how we can improve on this design using the new exception handler feature. I'm going to make a copy of what I have here and reuse that for my exception handler, and I'm going to rename this type into the global exception handler middleware just to keep it in the code base, and then let's move the actual exception handler into its own file. So how do exception handlers work in ASP.NET Core? Well, we have to implement the IExceptionHandler interface, and you will notice that this exposes just a single method called tryHandleAsync. It gives us access to the HTTP context, the specific exception, and the cancellation token that we can use to handle the exception. Now, it also returns a boolean, and you're supposed to return true if you are able to handle this exception successfully. Now, I'm going to reuse this part of the code that actually does the exception handling and get rid of everything else. So let's add an async statement here. Let's rename this to HTTP context, and let's rename this to exception. And now all we have to do is return true and also get rid of the request delegate, and we've implemented our global exception handler. Now, to make it work, we need to do a couple of more things. So first, we have to include this as a service. I need to say builder services add exception handler and specify my global exception handler type. So this has to be registered with dependency injection. And the next thing I need to do is to include the built-in exception handling middleware by saying app use exception handler. This is what's actually going to run the specific exception handler implementations. The next improvement I want to show you is the proper way to return a problem details response using the ProblemDetailsService. So instead of creating the problem details object yourself and serializing it into JSON and so on, you can rely on the built-in functionality that we have in .NET. So what I can do now is replace this logic here with something like this, where I'm using the ProblemDetailsService to call the tryWriteAsync method. This accepts a problem details context, and we can pass it the HTTP context to extract some information from the current request, the actual exception, and we can also initialize the problem details if we want to set something specific on the response. This method also returns a Boolean value, which is perfectly aligned with what we expect from the tryHandleAsync method. To be able to use this service, you also have to configure it with dependency injection. So I'm going to say builder services add problem details, and you can also customize this by providing a delegate here, and the delegate allows you to customize the problem details options. And what you can do on this options type is say options, and then you have access to additional metadata, the exception, the HTTP context, and the problem details itself. Now, why is this useful? Well, this allows you to configure some global variables that you always want to have inside of your problem details response, and a common example could be including the requestId, which you can extract from the HTTP context trace identifier. So let's test out this new functionality that we just introduced, and I'm going to send the same request again. It's going to cause a validation failure. We run into the exception in our use case. Now let's place a breakpoint here, and you'll see that when I press continue, we run into this breakpoint, and we can execute our logic that's going to write the problem details. And then this is what we get inside of our API. It's a more complete problem details object. The content type in the response header is application/problem plus JSON. So this more closely describes what the response type is. And we also contain the request ID, which we configured when setting up the problem details services. But I want to show you one more example of of how we can extend this. So let's jump back to the code. One thing that's really useful about the exception handler feature is that you can chain them. So what this allows me to do is to create multiple exception handlers, and then I can handle different exception types in the most appropriate way. So let's say I create a custom validation exception handler. It's going to be internal and sealed, and it has to implement the IExceptionHandler interface. We're also going to inject the IProblemDetailsService, and additionally, we can include an iLogger of ValidationExceptionHandler, and this can be useful if you want to log the specific exception details. Here's what the implementation might look like. So what I'm doing is checking at the start of this method if the exception that we are handling is a validation exception. I'm using the one from FluentValidation for simplicity's sake, and I'm capturing this inside of a variable. If it's not a validation exception, we can just return false and allow the global exception handler to process this. Otherwise, we are going to handle the validation exception in a specific way. We'll set the status code to 400 bad request. We are going to initialize our problem details context that we are going to pass along to the ProblemDetailsService when we call try write async. And one additional thing that I'm doing here is making sure that the response contains the errors that I'm extracting from the validation exception. It's available in the errors property, and I'm going to just expose that as an additional dictionary with the key of errors. And what allows me to do this is the extensions property on the problem details type, which allows you to return arbitrary data to your API clients. In order to execute this together with our global exception handler, we also need to register this with dependency injection, and I have to register it before the global exception handler. If we specify the global exception handler first, it's always going to handle the exception, so we have to make sure that the validation exception handler runs first. So let's test out if this is the case. I'm going to start the application and let's resend our invalid request, and sure enough, we run into a validation exception. Now if I press continue, and note that I have breakpoints in both of my exception handlers, the first one to trigger is the validation exception handler, and it's going to handle the specific validation exception, log the error details, set the response status code, and then extract the details that are needed to populate the problem details response. Finally, I can return this to the API client, and notice how it contains a lot more detail about the specific failure. There's also the errors property in the response containing more details about what's wrong with the validation. So if I were to omit this, so let me add some values here, and I resend this request, we're going to run into a different exception type, and it's also going to trigger the validation exception handler, but in this case, it's going to return false. And if I press continue, then we land in the global exception handler, which takes care of the exception and returns the problem details response as well. So this is how you can take care of global error handling in your APIs using the exception handler feature. Now, if you enjoyed this video, make sure to smash the like button that's going to be right below. And if you're tired of exceptions like I am, then go ahead and watch this video next to learn how you can get rid of exceptions from your applications using the result pattern. Check out my courses if you want to improve your software architecture skills, and until next time, stay awesome.